Okay, guys, we are back. This is part B of section 9.1. Okay, now we're getting into more of the meat and potatoes, if you will. These are the harder word problems. So we're still dealing with vectors, okay? And remember, vectors are identified by magnitude and by direction. Those are the two big identifying characteristics of vectors, magnitude and direction. So let's dive in here. A man pushes a lawnmower with a force of 28 pounds, that's going to be our magnitude, okay, exerted at an angle of 30 degrees to the ground. Find the horizontal and vertical components of the force. Assume, here's what's interesting to me. It says assume that the horizontal direction is positive and the vertical direction is negative. I don't, visually, this doesn't make a whole lot of sense to me, but they're talking about this being the 30 degrees because they want the vertical to be negative. Okay. When I'm thinking of, I mean, I guess they're thinking you're pushing down on a lawnmower as you're pushing it. So I guess I get that. But the force of 28, that's like saying our hypotenuse length here is 28. Okay, so this is our vector, okay? And they want to know the horizontal and vertical components, kind of like we've done in the previous two at the end of part A here. So this is like our I position, this is like our J position, okay? So really, the theta that we're going to use is not 30 degrees. The theta that we're going to use, remember, we always go around from our starting point. If that's 30, then our theta is 330, okay? If we do that and use a calculator, then we don't have to worry about what quadrant it's in and whether it's positive, negative. The 330 is going to give us the right answer, whether it's positive or negative for sine and cosine. So we don't really have to worry about that, okay? So again, our theta is 330 since it's 30 degrees in the negative vertical direction. Okay, so if we set that up, again, remember, horizontal, which is our I, and then our vertical, which is our J. So here's the formula, remember, for horizontal. Horizontal is going to be the magnitude, okay, which in our case is 28, times cosine 330 degrees I, okay? Plus the vertical is going to be 28 times sine of 330 degrees J, okay? So horizontal plus vertical. Now, obviously the vertical is going to give us a negative, so we're going to end up with a minus sign between them. But if I just poked it in a calculator, I'm not going to waste a whole lot of time. We know how to do this. So 14 root 3I minus 14J. Maybe I should have put that in purple. That would be my answer. Okay. So again, horizontal is always magnitude times cosine of the degree angle, and vertical is always the magnitude times sine of the degree angle. Okay, that's it. Okay, next one. A jet is flying in a direction of north 40 degrees east with a speed of 600 miles per hour. That speed is our magnitude. Okay, again, I told you the magnitude can either be force, it can be velocity, speed. That's what magnitude can represent in the real world in problems. So find the north and east components. Now, north is another fancy word of saying vertical. And east component is a fancy way of saying horizontal. Okay, so this is like my horizontal is like my I, remember, and my vertical is like my J. Okay, so that's what they're asking for, is the same thing the previous three have. Essentially find the horizontal and vertical components. They just ask for it differently because we're talking about actual physical directions. Okay, so again, picture person here. Let me explain, and I had wondered this for years, quite honestly. When they say north 40 degrees east, what does that mean? Why don't they just say northeast 40 degrees? Well, that's completely different direction. What they mean is if you are flying north, due north, and then you turn 40 degrees to the east, that's what they're talking about. Okay, so when they say north 40 degrees east, they mean, let me do it in a different contrasting color here. They mean you're flying north and then you turn 40 degrees east. So this is actually your vector. Okay, so if that is 40 degrees between the north and the east, then that makes our theta here 50 degrees, right? Because remember, we always measure our theta from the positive x-axis. So theta is 50 degrees. Now, and our speed of 600, that's the magnitude. That's our magnitude of 600. So we could actually label this vector 600 if you want. Okay, so that's how we get our vertical and horizontal components. So first, again, they wanted the north. Okay, the north, which is the vertical, okay, would come from 600, that's our magnitude, times, remember vertical is sine, so sine 50 degrees, okay, and our east, which is our horizontal, would be 600, whoa, not sure what happened there, 600 times cosine 50 degrees. Okay, so we've got the north is the vertical, the east is the horizontal. So the vertical gets the sine, the horizontal gets the cosine. All we can really do here is poke that in a calculator. So this gives me approximately, it does say to round to 2 decimal places, by the way. So approximately 459.63. And this one is approximately 385.67. Okay, so that's what you would put in your blocks for north and for east. Okay, this is east. Again, this is north. Okay, and that's miles per hour. Okay. So essentially what this is telling us is if you did Pythagorean's theorem, if you did the east squared plus the north squared, you would equal 600 squared. Okay. All right. Hope you understood that one. Let's move on. The next one says a river flows due south at 2 miles per hour. Now, let me just say here, due south. If you have got, you know, your XY axis here, and you are going due south at 2 miles per hour, that is a negative 2j. I hope you all see that. Due south is a negative 2j. There's no I. Okay, absolutely no I. Because we're not going east or west or horizontal at all. We're just going due south, which is down. That's why it's a negative 2, and that's j. J is our vertical. Okay, and a swimmer attempting to cross the river heads due east. Okay, so due east, again, draw a pretty picture here. If I'm going due east, I'm heading this way. That's the positive direction. That would be a positive 4i. Okay, the river's going due south, which is a negative 2j. The swimmer's trying to go due east, which is a positive 4i. And again, they've got the pretty picture there, but I like to see it in terms of like an XY plane. It says find the true velocity of the swimmer as a vector. assume that I vector points east and j vector points north. So again, we're going south. That's why it's a negative 2j. So literally, this almost seems too easy. I actually kept looking at this one going, what am I missing? But you're literally just adding them together. This is 4i minus 2j. That's your answer. Okay. True velocity of the swimmer, you just add those two positions together. Okay, easy peasy. Next one. The speed of an airplane is 275 miles per hour relative to the air. The wind is blowing due north with a speed of 25 miles per hour. In what direction should the plane head in order to arrive at a point due west of its location? Round your answer to 2 decimal places. Okay, now, this one's kind of a doozy. So let's first draw, whoops, I want that in black. I always like to start with a picture of my XY coordinate plane here. We'll get back to the airplane in a minute. Let's first talk about wind. Wind is blowing due north at a speed of 25 miles per hour. So here's wind. The magnitude is 25 and it's going due north. So that is like 25J. Okay. I hope everybody's with me there. There's no I. It's just 25J. J, remember, is our vertical position. Now, the airplane has a magnitude of 275 miles per hour. We're trying to figure out what direction the plane needs to head so that the wind blows it, and it's trying to end up, the plane is trying to end up somewhere out in here. We don't know where, but due west. Okay, so somewhere out in here due west is where it's trying to end. And that is, we don't know what I, it's going to be a negative question mark I, plus 0J. Okay, I'm intentionally writing the 0J part so you can see it. Now, if you've got an airplane flying and it needs to end up due west, but there's a north wind pushing on it. So everywhere the airplane goes, you know, there's this north wind pushing on it of 25. It's going to end up having to be down in here somewhere, right? So that once the wind pushes north, it's literally like pushing it up to the due west position. You all kind of see that? So the blue line represents my airplane where it should be. Let's see if I can erase. Oh, okay, that worked. Not sure what I did there, but okay. So this represents my airplane and it is 275. Now, here's the deal. I don't know what its I and J are. Okay, that's just its velocity. Okay, or that's its magnitude, I should say. So I don't know about its I and J. Its I and J are kind of up in the air. It's question mark I, question mark J. Okay, so what I do know though is that the airplane plus the wind needs to equal the purple position. So the blue position that's being acted on by the red wind needs to end up in the purple position. Okay, so I need to know what this theta is. I need to try to figure out what that theta is. Okay, and I know then that whatever that theta is, okay, let me go over here, that my 275, it's going to be 275 cosine theta I plus 275 sine theta J. Okay, and actually what I ought to do is make them both negative. Because I know we're going to be down in the third quadrant. So since I'm just making this theta up to the negative x-axis, I'm not going all the way around. I think I'm going to change this and make these both be negative. Whoops. So negative 275 cosine theta minus 275. Oh, there's my I. I missed my I. minus 275 sine theta j. Now, so all I really know here, this due west, my purple location, I do not have any clue what this is, okay? So I'm going to leave it alone. I'm actually literally just going to act on my J positions. This position, and this position, okay? So I know, actually, no, I'm going to make these back to plus. I'm sorry. You'll see it when the picture comes out. You'll know what theta should be. So we are going to say that 25J, that's the wind, whoops, plus the 275 sine theta J equals 0J. Okay, that's our position. Now, they all have J in them. We can just literally cross that out. So 25 plus 275 sine theta equals 0. I'm just working off the J position. I only need to find theta either using sine or cosine. I can't really use the horizontal position because it didn't tell me how far west it needed to end up. So the only point of reference I have is that all three things that I'm given have a J position. So that's the side I've got to use, is the vertical, okay? So, and whether the 275 sine theta is positive or negative, it really doesn't matter. You'll see here as we solve it. So this is going to tell me then that 275 sine theta equals negative 25. So sine theta equals negative 25 divided by 275. And then if you take the arc sine of that, okay, that means your theta is negative 5.22. Now, if we had had the 275, if I'd left it positive, then it would have been a positive 522. And you can kind of see from the picture, it doesn't really matter. This theta right here is 5.22 degrees, okay? Now, it's negative because it's going down, but you know, whether your theta is positive or negative, you can tell from the picture what it is. Now, they want the answer in terms of south blank degrees west. So that's how they had the answer. They had south box degrees west. Okay, so what that means is they want the position, kind of like, remember the last one where we had north 40 degrees east? They want it south so many degrees west. So if I draw another little XY coordinate, south would be going this way, and then so many degrees west before we get to our airplane. They want this degree measure, okay? I should have put my X inside here. They want this degree measure in there. Well, I know that this one out here is 5.22. Sorry, that's so little you probably can't even see it. So how do I get that? Okay, I take 90 minus 5.22. Okay, so 90 minus 5.22 degrees is going to give me 84.78. And of course, that's on a dead spot at my board. So 90 degrees minus 5.22 is 84.78 degrees west. That is my final answer. Okay, so you have to see how they want it. If they wanted it, if they had asked for it west, so many degrees south, if they had said west, here's your block, degrees south, then it would have been the 5.22. Because then on that one, that means you're headed due west and you turn so many degrees down before you get to your plane. Well, that was the 5.22 that we found. So it depends on how they ask the question, which direction comes first. I hope you all understand that. So again, south means you're headed south first, and then you turn toward the west 84.78 degrees, so that what you have left up to the negative x-axis is 5.22. Or if they would have asked it this way, the west first, then you would have headed west first and turned south 5.22 degrees. Okay, so mine asks for the south and then the west. Okay, next one. Woo. I told you some of these get tricky. Okay, a pilot heads his jet due east. The jet has a speed of 425 miles per hour relative to the air. The wind is blowing due north with a speed of 45 miles per hour. Assume that the I vector points east and the J vector points north. So express the velocity of the wind as a vector in component form. Now, first of all, over here, we've got jet. If it's going due east, that is, sorry. Actually, they asked for the wind first. I apologize. So first they have wind. Sorry, I was going on the wording in the problem and not what they're asking first. So the wind, it says, is blowing due north. So that means if we've got this, wind is going due north. So that is like 0I plus 45J, right? Due north. So in component form, don't forget the word component. In component form, that is 0, 45. And again, you're going to have to use those little brackets in the vector menu on the right side. Now, the velocity of the jet, it said the jet is headed due east. So if I've got this, my jet is headed due east. So that's that direction. So that would be 425 I plus 0J. Okay, so again, in component form, okay, that is bracket 425, 0. Now, find the true velocity of the jet as a vector. Well, this goes back to that swimmer one. Okay, true velocity as a jet of the jet as a vector, you add the jet and the wind together. Okay, so if you add the jet and the wind together, this is jet plus wind, you literally have 425, 45. Again, in component form, I assume. Now, find the true speed. Okay, now look at the difference between how these are asked. True velocity as a vector. Again, vector, you got to give two positions. Okay, now the true speed is the same thing as the magnitude, or as, well, I don't want to use J. If we're talking vector, it's the magnitude, it's the absolute value of the positions. It's like if you drew a right triangle with the horizontal and vertical positions, what would be your hypotenuse? Okay, so the true speed is where you use your magnitude formula. Okay, so that is going to be 425 squared plus 45 squared, and then of course you take the square root of that, you poke all that in a calculator, and you get 427. So the true speed of the jet is 427. It's actually, the wind is helping it a little bit. Okay, it's going a little faster. Now find the direction of the jet. Again, we have got to draw a picture here and then see. Now this is find the direction of the jet north and then turning so many degrees east. So you always have to make sure that you're going in the direction they want you to here. So if I draw a picture, let's start again with our XY plane. Okay, the jet is supposed to be going east, but of course the north wind is actually pushing it. Okay, so the jet's going to end up going up a little bit. Okay, the wind is going to push it north a little because it's a north wind. I probably drew that a little too far, but that's all right. So if I keep drawing here and make my right triangle, okay, this position was 45. That was the speed of the wind, right? The jet was 425, and this was 427. So how do I find the direction? Well, I need to find theta. I need to find this theta. That would give me my direction. Now, actually, once I find theta, it's going to be 90 minus theta. Okay, so this here is going to be 90 minus the theta because they want the north and then so many degrees east. So what they really want is this part right here. Okay, it's 90 minus theta. Okay, so how do I find theta? You can use any of your trig functions, whatever, you know, trips your trigger. Tangent theta is 45 over 425. So if you do the arctan, that gives you approximately 6.04. Okay. Now, what did they want if we look up above? Round your answer to 1 decimal place. Okay. So now my answer here, 90 minus theta, 90 minus 6 is 84. Okay. And actually, I should probably be more exact since they want it 1 decimal place. I'll put 84.0. Okay. I don't know if they would count just plain 84 wrong, but if they want 1 decimal place, I'd probably put 84.0 to be on the safe side. Okay. All right. Next one. Okay, this one's kind of a doozy. Hang with me. Actually, I may stop here. I'm going to stop here and finish up these last problems in part C. Okay, so I will stop here for part B.